Wow, that's impressive. Okay, good afternoon, everyone. Thank you for coming to this session. I don't know how much you know about crypto, but people are usually scared about crypto talks because cryptographers, they like talking about complex operations and S boxes and operation in arithmetic in RSA, things that tend to be pretty boring, have a lot of math, and it's also boring to me. So be assured there won't be any complex math in this talk. I tried to make it, relatively approachable. So I don't know if you know me, but I've done a lot of crypto maybe for the last 12 years. I've done ciphers that you may use in your phones, in your laptops, stuff that ended up in a Linux kernel. And today I'm going to talk about more high-level stuff, applications in the context of IoT, machine-to-machine, and V2V. Okay, so IoT is a bit of a buzzword, so let me try to be maybe more specific. So we see connected systems in many industries. It's not in one specific application. We see it in connected cars, in healthcare, with connected equipment, in transportation, oil and gas, so nothing really new here. That's the slide that you see at the beginning of every IoT talk to motivate what's coming after. Let me try to be again a bit more specific in the context of cars. I can only tell so much because of NDAs and stuff, but typically it can be used in two different ways. For cars to receive information and cars to send information. So you can imagine cars sending out telemetry data, and you can probably imagine cars receiving stuff like firmware updates or other information. So this illustrates the fact that in many IoT systems, you have two main types of topologies. So many-to-one and one-to-many. You also have sometimes many-to-many, each device talking to one another, but it's less frequent than the many-to-one and one-to-many topologies. So if you do a comparison with, for example, mobile messaging like WhatsApp, so WhatsApp and all mobile messengers are many-to-many. Everybody can talk to everybody. Okay. So talking of WhatsApp and other applications, I don't know if you remember a few years ago, and maybe in 2012, nothing was really encrypted because people barely know about the concept of encryption, end-to-end encryption, to make sure that the message you send to your friend can only be decrypted by your friend and not by anyone else. So that was like this here maybe a few years ago. And then there's this guy, Edward Snowden, that you may have heard about. He went out there and published all these documents and said, hey, look, everybody's looking at reading your messages, and NSA is doing what NSA is doing, and other organizations are doing the same. And people were like, oh shit, maybe we want to have some degree of protection. And that's one of the reasons. There are a few other reasons, but that's one of the reasons why today in 2019, you have at least some reasonable level of encryption, of end-to-end encryption in most mobile applications, in most mobile messaging applications, even Skype, even Telegram, iMessage to even WhatsApp. So I don't know if you know, but the WhatsApp, you don't see any crypto, you don't have to do anything special, but you might see this yellow box telling you that the session is encrypted. So it means that under the hood, there's a lot of complex and boring crypto operations carried out between your device, the device of the other people, and the servers of WhatsApp. So there are some limitations. It's not perfect, but it's good enough for most of us. Okay. Now, if you compare this with the situation of IoT, machine-to-machine, so it's very different, where we are at a stage of maturity that is much lower, much earlier than the one of mobile messaging. So we can reasonably say today that nothing is really encrypted in the context of IoT. So of course, it should not be taken too literally. You have some stuff that is encrypted, some use of TLS. And for many people who are not cryptographers, and I don't blame them for that, I wouldn't want my daughter to be a cryptographer, that's fine. But many people hear TLS and they say, oh, that's fine, we use TLS, SSL, whatever, so it's encrypted, I can check the box. The auditors will see this and it's fine. But in practice, it's not enough. In many cases, TLS is not enough. And I will explain you why. So what we can expect is that in the future, in a few years from now, in 2, 3, 4, 5, 7 years, I don't know, we'll have the end-to-end encryption technology for these IoT systems. And it's a completely different game than mobile messaging, and I will explain you why. And it's a harder problem to solve as well. So to be more specific, in many contexts, in the IoT context, your device will not directly talk to the backend. It will not directly talk to another device. It will use a message server somewhere in the cloud or in a DC somewhere. And for example, this kind of relay server can be called a broker in the context of MQTT. And this server will be in charge of, let's say, sending out the messages to all the recipients and queuing the messages when they need to be distributed to other messages, because most of the time you don't have peer-to-peer connection. So you would have, in the best case, security, for example, like TLS, between your device and the server in the cloud. For example, if you use Google or AWS or Azure or IBM solutions, they have an IoT cloud platform. And they give you, SLAs and the guarantee that their message server will always be running. So they will receive your device's messages and they will distribute them to your backend or the other way. But most of the time, they will be able to see the content of the messages. They will be able to modify the content of the messages, to drop messages, and to inject new ones. So you really have to trust these cloud providers. And these cloud providers, they may be based in a foreign jurisdiction. And of course, you may want to transmit privacy-sensitive data, business-sensitive, trade secret, and other stuff that might also be safety-sensitive. So there's very good reason why we'll need this level of end-to-end encryption. I think it's obvious to any cryptographer. It's obvious to many people, but the solution is very, very far from obvious. Okay. So what we're going to end up with at some point, I can't tell you when, is this end-to-end security where you don't need to trust the gateway, the cloud provider, or the message broker, however you call it, and the message can only be read by the parties, by the devices that need to read it, and not by anyone else, which is essentially how it is today for mobile messaging. Although, like I said, there's a number of caveats. But there are a couple of reasons why it's hard to solve. I don't know if you've already tried to solve this problem in your job, but if you work with IoT platforms, it's not like a normal computer. It can be a completely different beast. Sometimes you don't have any storage, you have small CPU, you have to care about battery life. So there's no one-size-fits-all solution. You sometimes have to create bespoke designs. And there's, of course, the key management problem that I will come back to in the next slides. To give you maybe one more concrete example, I don't know if you've used MQTT. Do you know what MQTT is? Yeah, at least one person, yeah. Okay. So we hear that MQTT is very popular, but it doesn't look like it's that popular, at least in this room. Well, it's the only IoT-only protocol that is supported by the cloud platforms of GCP, AWS, and so on. So it's exactly what I mentioned before. It's this kind of publish-subscribe system where you publish messages. So you're not sending messages to one specific device. You're tagging your messages with a label, a name, that is called a topic. And then to receive messages, you don't say, oh, I want to receive messages from device XYZ. You say, I want to receive the messages about this stuff, about this topic. And then you're going to receive all the messages tagged with this topic, whatever the device published the messages. So it's super simple. It's a very boring protocol. If you look at the specs, it was designed by IBM in the 80s, but it works really well. It's very simple, very lightweight. So it's used a lot. And in this context, one possible approach that we might want to consider is instead of modifying the cloud server, you just had a new client that will act as the crypto manager or the key management server. And this guy will be in charge of managing the crypto and making sure that all the devices can communicate securely. So that's the approach that we're following in our company. So not to do a too obvious commercial pitch, but I think that's the best approach because you're not going to ask Google or Amazon to modify their servers to introduce end-to-end encryption. They can't. And that's one of the reasons why you cannot use the same crypto for IoT as you use for WhatsApp or Signal or Wire or Telegram, whatever. Okay. So now let's discuss maybe some more technical details. So I don't know if you've worked on IoT platforms, if you had to program small computers if you worked with, I don't know, STM32 chips or AVR, 8-bit AVR platforms, or this kind of thing. But it's not only about speed and memory, although of course it's about speed and memory. If you work with the small platforms, you have sometimes severe speed constraints. You're not working in a 3 GHz CPU. You might have to deal with a 32 or 16 MHz CPU and have some severe latency constraints. You may only have like 256 bytes of RAM in certain cases, sometimes more. You don't always have a file system. You can't always have persistent storage. And even sometimes you don't have any PRNG, no random generator, at least no reliable random generator that you can use for cryptographic applications. And that's a big problem because in most crypto applications, you need strong randomness. You need strong random numbers to ensure a good level of security. And when you don't have it, what do you do? Well, you have to find a solution. Sometimes you don't even have a clock, a synchronized time. So how do you verify a certificate? How do you verify the certificate expiry date if you don't have a clock? Well, again, you need a solution. And sometimes you have also many constraints in terms of bandwidth, of connectivity. Maybe your device can only be connected to the network, I don't know, maybe 5 minutes per day, maybe 1 every 2 days, maybe 1 hour per week. So you have to manage this, and it's really hard in terms of key management of crypto. And of course, you can't always say, oh, I know the right solution. You have to use this cipher I've read about on Twitter. You need to use this standard. You need to use this nice elliptic curve designed by Dan Bernstein or whatever. Sometimes you can only use what's available on the device. You have a crypto accelerator. You have the library by the manufacturer, and that's the only crypto algorithms you have. And how do you do public key crypto when you only have private key crypto, symmetric crypto? Well, of course you can. There are some workarounds. You can do, hash-based signatures, but it gives you huge signatures that are unusable for most IoT applications. So that's the difference between theory and practice, between academia and industry. In academia, everything is perfect. You can choose your cipher. You don't have many constraints. But in practice, you have to deal with a whole lot of constraints that make your life very complicated. So the US Standardization Institute, NIST, is working on a project called Lightweight Crypto Project, and the goal of this project is to develop, to standardize new ciphers that will be, let's say, small enough, light enough for IoT platforms. But they can only address part of the problems, only the performance problems, and not all the other problems. So I'm not blaming them for this, it's not their job, but in practice it's something you have to consider. Next, last but not least, the biggest problem in crypto. So encrypting stuff is easy. Decrypting stuff is easy too, if you have the key, of course. But the hardest part is, what key do you use? How do you manage the keys? And if you work with crypto engineering in practice, that's a real problem if you want to do it right. If you want to manage key security, if you want to make sure that if a key is compromised, then it can be revoked securely. How do you make sure that every device has their own unique key and that everyone knows the public key of the other devices? There's no simple solution. It's about trust models. You can use like the Web of Trust model or PKI, but PKI are also a big mess. If you already deployed a PKI, you know it very well. There's a problem that in the IoT context specifically, like I mentioned, they're not always online. So you can send a message to a device and tell it, okay, please update your key, or please forget about this key. But if the device cannot receive the message, how do you do? You wait for an acknowledgement, but you may never receive it. So there are many problems like this, and of course, what do you do? How do you do if you don't have public key? You can't use certificates in public key crypto. You need to work differently. And sometimes the message size is fixed. The customer will tell you, oh, we can only have messages of, I don't know, 247 bytes. No byte, and that's it. And you can only send a limited number of messages per day. And you're like, oh shit, I cannot add a signature. I cannot even add an authentication tag. And yet you have to provide them with a high level of security, or level of security that is good enough. So there are many problems, and also if you want, you may want to emulate this concept of group messaging. So if you create a group, for example, on WhatsApp, the way it works internally, without going too much into the details, but you can add new members to the group, and you can kick people out of your group. So the way it works is that the people that join the group at some point, they won't have the cryptographic keys to decrypt the previous messages sent within the group, even if they recorded the encrypted messages before. Likewise, if you kick someone out of the group, they won't have the keys to decrypt the future messages sent within the group. So they can just record the encrypted traffic and deduce the keys sent within this group, because it will be encrypted with different keys that they don't have the information needed to decrypt. So how do you implement this kind of paradigm in the IoT context? Well, short answer, it's hard. It's possible to some extent, but it's really hard. And how do you implement even simple stuff like key rotation? Key rotation is very simple. You have one key and you update this key. In the simplest setting, you will just hash the key. So if you use a one-way function, you hash one key, you get a second key, so you can determine the first key from the second one, because the one-way function is one way. So you can go back in time. But it's easier than it sounds, because how do you make sure that everyone rotates their key at the same time? So that's another problem we have to solve. So now you might say, okay, why don't we just use what is used, for example, in WhatsApp, in Signal, which seems very reliable. When you open your WhatsApp, you don't have most of the time you don't get any error message. It seems to work most of the time. You're not really sure that the messages are encrypted because you can verify it, but you just have to trust WhatsApp. And you have to trust that they provide you with an application that doesn't have any backdoor, where the keys are randomly generated, and so on. But there are many reasons why we cannot use the crypto of WhatsApp and Signal and Wire and Telegram and Skype in IoT. Oh, by the way, the crypto you use in WhatsApp, in Skype, in Facebook Messenger, secret conversations, is almost the same. It's almost the same. It's called the Signal protocol. Wire is something that is slightly different, but very, very similar as well. Telegram uses something that I don't know how to describe, and I don't know if it works, but they think that it works at least. I don't know it very well. But one reason why you can't use this messaging protocol in the context of IoT is that, first of all, you need many more messages. Every time you start a new conversation, you need to send one message to the server and receive another one, because the server needs to tell you which key to use, and only then can you start sending a message to the other party. And also, these messages are pretty big. They contain several keys, and these messages might be too big for many IoT platforms. So it's optimized for the messaging context, where you send one message, you receive another one, you send a file, you receive another file, and so on. And it's not what you need in IoT. Some people try to use it in IoT, but it's really, really not a good idea. Okay. So I've talked a lot about crypto, but I don't want to give you the impression that crypto is all you need to secure your IoT platforms, because it's only part of the solution or part of the problem, depending on how you see it. We only talked about communication security, specifically end-to-end security. So it means confidentiality, hiding the content of the messages. It means integrity, authenticity, making sure that the messages you receive have not been modified by anyone, and they have been sent by the person that sent the messages in the first place. But there are many other things to consider. And a very important one, of course, is endpoint security, because if your endpoint is compromised, if your device is compromised, then it's useless to have end-to-end encryption, because the attacker can get the key or the messages directly. So you also want to use a secure OS to protect the keys reasonably well. In many cases, you cannot use a secure element. You have no secure storage, so you do your best. The ideal case is, when the security expert, they will tell you, oh, you need a secure boot, you need a secure element, you need this. But then you end up with a device costing you, I don't know, maybe $10 per unit, when your budget is $2 per unit. So it doesn't always work. There's also you need TLS. I'm not saying that this end-to-end security can completely replace TLS. The two are complementary. You need TLS for the client-server connection. And within this TLS tunnel, you have the end-to-end security protocol. For example, you need TLS when you establish a connection in MQTT. If you send credentials, if you use password-based authentication, of course you want the password to be encrypted. Because before talking with another device, you will talk with the server. And you will be authenticated to the server, and only then can you send messages to other devices in the IoT network. And then you might also be worried about other notions like anonymity. Do you want the server to know who you're talking with? And do you want to give out your list of contacts to the server? So in the IoT case, it's maybe less critical than in the mobile messaging, in the personal messaging case. But if you look at WhatsApp, for example, WhatsApp, they know all your contacts, and they are matching these contacts with your Facebook friends, so you know how it works. Some other systems are trying to have some kind of privacy-preserving solution, whereby the server doesn't know the names or the phone numbers of your contacts, but can nonetheless determine if one of your contacts is using the same application, and then they can match you with this contact. So it's a bit less useful, less relevant in the case of IoT, but I've seen some cases where you also need this kind of contact matching. Okay. So then I'm not saying that all the applications need end-to-end security, but many applications, at least from my experience and from my perspective working with a number of customers in this field, you can see it in two ways, like securing existing deployments, and you can also see it as an enabler, because maybe many companies are a bit scared of using IoT platforms because of the security limitations. And now if we had an end-to-end security solution, maybe they would be more willing to do certain applications, or maybe to send privacy-sensitive data to the cloud and then back to other devices. Okay. And fundamentally, the goal of this is to avoid having to trust a third party. Well, you have to trust it to some extent, but at least you know that they will not see your messages. They might have access to some sensitive information, but not to the content of all the messages. And of course, this might help you dealing with some regulatory compliance issues like GDPR and others. Okay, so that's pretty much it. I hope it was not too cryptographic and not too obfuscated, and I will be available for any question you may have today and tomorrow. Thank you very much. Dziękuję.
Thank you, John.